Thank you everybody for coming. I want to start off by telling you who this presentation before, and it's not for you, it's for me. This is the presentation that I wish I had a year ago when my team and I had a challenge in front of us of building a large, maintainable, scalable, native application, but written entirely in React Native with no prior experience building native apps. So let me tell you a little bit about myself. My name is Terlson. I'm a lead engineer at InterNations. And I'm going to tell you about the project that we have built, and it is important to understand kind of a little bit about my background. So I started about 16 years ago building apps in ASP before graduating to .NET. Once REST became cool, I started building with ASP, .NET MVC, building front ends in Backbone. Before also building with Node, and then moving exclusively into the front end. But for the last 2.5 years, I've been building exclusively with React Native. In fact, this is the first commit that I have with React Native code. Isn't it cute? So you also have to know a little bit about the company and the product that, or the company that I work for and the product that we're building. So InterNations is a global social network for expats. So I myself, born in the United States, living here in Germany, I am an expat. We organize thousands of events and activities for people around the world. We have over 3 million users, and the company is roughly 100 employees in size. We actually have 2 applications in production today, one for iOS, one for Android, and they each have about 50,000 users. But these applications were developed by external contractors. So there's actually no one in InterNations who knows how to develop these hybrid applications. So they were built hybrid so that we could continue to build web applications, and that's how we rolled out new features for them. But that hybrid element definitely shows in these apps. They are slow to load, they are slow to respond, they feel absolutely terrible. So my team embarked on a mission to slay these hybrids and replace them with React Native. We had several objectives in mind from the very beginning. First-class native feel and performance. It has to be good. This is the #1 complaint, as I mentioned, for those hybrid apps. Second, we're going to build iOS and Android simultaneously. So this means that anywhere we can take design consistency in order to shortcut our development time, we will do this. And the third point is that we need to build offline first. I'll talk about this a bit later, but this is absolutely critical to having a well-performing, nice-feeling application like ours. And we also need to support a broad range of product features. So InterNations as a platform has a lot going on. I'm talking events, search, messaging, users, groups, contacts, maps, push notifications, activity feeds, and more. So this is not a small application. And to do it all, 3 front-end engineers, 2 back-end engineers, and me. No one's built a native app before. These are all web people. So imagine you're in this situation. Now what? What do you do? How do you possibly begin? Well, we began by focusing on writing solid code. This is solid JavaScript. And it might seem a little bit boring, but these are the 2 main weapons that you have to write solid JavaScript: Prettier and ESLint. Does anyone here not use Prettier? Correct your ways. You are wrong. Prettier objectively makes you more efficient. It just removes keystrokes, and it's fantastic for teams. No more bike shedding discussions into stupid style debates. Just write good code. And ESLint. Would anybody admit to not using ESLint? No.
TSLint.
TSLint. Okay, fair enough. So ESLint, it's a default, but it's hard to understate how critical this tool is. Static type checking is critical. Consider that in React Native, a JavaScript error doesn't land silently into someone's browser console somewhere. If a JavaScript error occurs, the application crashes. And when applications crash, people uninstall your app. It is absolutely critical that you write solid JavaScript, and types objectively make your JavaScript more reliable. I cannot imagine anybody writing a large, serious application in React Native without using Flow or TypeScript. So we use Flow. The good part is that it prevents many classes of errors, and it significantly reduces your refactoring time. But the bad parts, the library types are often missing or outdated. Error reporting is bad, although it's getting better with the latest release. But they are somewhat consistent, so you can kind of start to see patterns and work your way through some things. It plays terribly with Redux Saga, and issues on GitHub are pretty slow to get fixed. So with the combination of these tools, sometimes random shit occurs. So I heard about Flow's spread annotation, and I wanted to give it a try. But I couldn't because ESLint didn't yet support the syntax. Well, I thought, okay, no problem. Flow has a fallback for this. It's their comment syntax. So I tried that, but Prettier stripped out the comments. So it's like this vicious cycle. So sometimes things get in the way, but thankfully you won't run into this today. This problem is fixed. But next time I would probably give a more serious look into TypeScript. Because issues on Flow are kind of slow to get fixed, and because TypeScript has the support of Microsoft and the Angular community, I suspect it will have more staying power than Flow. So if I were to start a new project today, I would probably look more heavily at TypeScript than Flow. Step 2, release. Might seem a bit early, but releasing first is a great way to make your teams more productive. And React Native has some pretty interesting value to offer when it comes to setting up nightlies, as well as continuous delivery. So we use 3 main tools for this: Jenkins, CodePush, and Fastlane. So Fastlane is awesome whether you're doing React Native or just normal native applications. It makes your builds way saner, especially on iOS. Jenkins, of course, for running your CI. But CodePush bears a special mention. So CodePush allows you to deploy JavaScript direct to your users without going through the App Store. And when people hear about this, they often think, oh, well, surely Apple will shut this down, right? They're not going to allow you to go around their processes. Well, even if Apple were to shut CodePush down tomorrow, it is still a fantastic tool for organizations. Consider that with CodePush, you can deploy your native application code to all of your test devices, all of your internal testers, instantly as a part of your CI pipeline. This is something that makes your teams more productive. It's a fantastic tool. In React applications, the discussion always begins with state. What to do about state? There's so many different options out there. So this is the state of the JS survey 2017 results. Might be a little hard to see from the distance, but for the libraries from lowest to highest, left to right, we have Falcor, Relay, MobX, Apollo, GraphQL, and then Redux. So I hope this graph tells you something about the relative popularity of these different solutions. Notably, Redux is way ahead, and we use it as well. So Redux is the standard, most popular solution. And so there are some advantages to doing this, right? Like all the tools, all the libraries are going to support it. People have run into all the problems that you're likely to face, so you don't have to be the first one to work your way through it. It gives you a functional style, a functional approach, but it is rather boring. But we use Redux like a database, and I think boring is a great quality in a database. I do not want my database to be exciting. But one of the most interesting things that Redux gives you are actions. We use actions throughout our entire application, and we use it to separate concerns, that is, keep different parts of the application completely isolated from other parts, and we use it for traceable side effects. So using our debugging tools, we can watch all of the actions in the system occur, and we know exactly what effects those actions have. We store our Redux state in what I just made up to be called normalized collections. So this is, you have to normalize your Redux state for various efficiency reasons. But we do it in a slightly different way. So there are tools like Dan Abramov's normalizer, which you can use to make this easy. But because we use Flow, we actually control this manually. And the advantage is that we have 100% type annotation on our state. And this is fantastic. So how do you build a normalized collection? It's really easy. You just need 2 keys, and I'll talk about the third. One is the IDs. So store all of your IDs separate from the actual entities. So that's the ID array. Then you have the by IDs, which are the entities themselves. And now you have a lookup table where if you know the ID, you can just get the entity straight out. It's not O of n complexity, it's O of 1. We also do what I call indexing. So this is a bit analogous to MySQL index, if you will. You can actually compute indexes within your Redux state to make selection more efficient. So consider, if you have messages as a part of conversations, maybe you store all of your messages together, but you want to group all of the messages for a certain conversation. So we do this when you actually receive the data rather than when you bring it out. Because when you bring it out, you're in the critical path to render. And in React Native, you want to optimize this path as much as possible. In order to achieve this, you only need a handful of helper functions. IDs insert, by ID insert, by index insert. And with that, you actually get a fairly expressive, easily managed state reducer function. So hopefully that looks easy to manage. So getting it out, selector functions. So this is different than a typical map state to props function in that we say a selector returns a single value, and in that way it becomes reusable. If your selector functions are returning the specific props that a component requires, it's not nearly as easy to reuse. And the great thing is that, again, we're able to 100% type annotate these, we namespace them, we unit test them, and we cache them heavily with reselect. So now that we have the state all put together, the challenge is, how do we actually build a UI in React? We haven't actually put anything on the screen yet. We're just storing information. And we build UI in React in a very functional way. I wrote an article on Medium about this, so if you're interested, you could check it out. And I'm happy to say that Dan Abramov himself agrees with almost everything that I said. So kind of a big deal. But the functional UI is broken down into 3 parts. The first part is a presentational component, which is basically just your typical dumb component. But it's important to understand that this is a function, right? So these are stateless functions which simply compute visible things, right? This is React Native. You are not generating HTML. It is not text. Every component that you see is a function invocation with arguments, right? So this means typical best practices for writing functions apply. This means, single responsibility. Make sure that your prop makes sense internal to the function. Separation of concerns. All of this. So Our presentational components are completely free of business logic. We document them in Storybook, and we actually don't even bother testing them. They tend to be so isolated, so free of anything that it's just not even worth testing. We played around with snapshot testing, but in practice, the breakages in the snapshots weren't really helpful. So I can show you what one of these look like if you haven't seen. So the first part, styles, of course. Styling in React Native is hopefully familiar to people, but quite easy. Followed by type annotations written in Flow. You'll see that we have these t-member, t-message, so these are global types that we use throughout our application. Here's the component itself, written as a stateless functional component, and here is the composition of the UI itself. So pretty typical. Hopefully that gives you an idea of what I'm talking about. Sorry, if I'm going too fast through the code and people want to spend more time, please raise your hand or let me know. So the second part of the functional UI are higher order components. So higher order components are the definition of your UI's behavior, right? So the first part, presentation, second part, behavior. When I first heard about higher order components, I kind of understood them conceptually, but I couldn't actually think of a higher order component that I might consider writing. So maybe this is true for you as well. I suspect everybody who's using Redux has used at least one, and that's the connect function. React Redux's connect is an example of a higher order component. And I listed out some other examples here. So these are actual higher order components that we use in our application. Things like fetching data when the component mounts, pull down to refresh, showing modals, action sheets, swapping out the content for placeholders, locking orientation, infinite scrolling, and error boundaries. Error boundaries are critical. Remember that any sort of access of a prop that ends up not being there is going to crash your app, right? So wrap things in error boundaries. The third part to the functional UI are what I call composition layouts. So now this is where you put everything together, right? We have abstract presentation, we have abstract behavior. Now we need to build a concrete screen. That happens in the layout. So here's an example of composing behavior. So my screen is able to access state with the connect function. It is dispatching an action to fetch data when it mounts with the data higher order component. And it infinite scrolls with the help of the pagination higher order component 10 at a time. So is anybody not familiar with compose or the composition function? No. Okay, great. So we have the behavior. Oh, did someone? It's okay. The second part is the composition of the presentation, right? And I say composition very directly for a reason, right? Again, this is not presentation code, right? It's got the angle brackets, but this is not HTML. This is not actually displaying anything directly. When you look at Flex View here, for example, or the swipeable list, React Native is invoking functions behind the scene. And when you take the result of one function and give it and execute it with some arguments and give that result as an input to another function, that is a composition, right? So this is a composition of presentation, a composition of behavior put together to define your concrete screen. So let me give you an example of what that can look like. Unfortunately, I have to stand sideways. So again, we have some flow magic at the top. defining some types. If you've wondered how to type annotate your connect function, this is how you do it. You actually have to import the type connector, the generic type connector from the React Redux library in order to do it. And then you create your connect here, used here. And then, yeah, you do exactly the composition that I mentioned before. So step one, compose all of your functionality with the help of these 3 higher order components. Step two, compose your UI, right? So these are all abstract, reusable, stateless functional components that are being composed together to form this particular screen. And then at the end, you finally pass your UI into your behavior, and that is your final screen. So this is a fantastic way to put together your application. Yes?
The compose function you use, where do you get it from? From Redux?
Lodash. It's flow right from Lodash.
But Redux comes with a compose function itself, right?
Yes, it does.
Is it the same? Or?
Yes, it is.
Does that just function composition?
Yes. Yes. What this compose function does is because it's actually reversed. So this function here, its result is a component, right? Higher order components are functions which return other components, right? So you invoke a function, you get a new component out. Well, this component here actually takes as an input the entire UI. So step one, all conversations is given as an argument to the pagination component, or the pagination higher order component. Then that returns a new component, which is given as the input to the data higher order component, etc. And so it flows from right to left. Good question. Good. That one. Yes?
When you're using compose to compose higher order components, have you ever run into the problem where where one HOC depends on another one and you have to declare them in a certain order when you're using compose, or is that
certainly
ever been an issue?
Yeah, I mean, you definitely want to limit that case, but there are some interesting things that you can do, especially with flow. So for example, what we actually do is export from our higher order component a type. And that type describes all of the props that higher order component will give to whatever component you give it. Yeah? So we use that as sort of a communication mechanism to say, strictly that these are the props that you're getting out of this higher order component. Yeah, so an example of that is right here. So connect props are the props coming from the connect function. The data props are the props coming from the data higher order component. And the pagination props are from the pagination one.
So,
Yep.
So do you get like an error at build time or compile time if you try to pass it the wrong, if you try to use it in the wrong order, or declare, or give it the wrong props?
Well, order doesn't take a play. Maybe I misunderstood. The higher order components are completely isolated, right? So you wouldn't make it such that higher order component A depends on higher order component B's props, because why wouldn't you just make B as a part of A, right? So the higher order components exist in isolation. They're truly independent. Right, and then when you compose them together, though, you often need to give whatever props they're spitting out to your UI, right? So, an example, the onload next page function comes from the pagination higher order component, and so if the pagination higher order component implementation changes to export different props, well, then you get a flow error at compile time. Yeah. Yes. Here.
on the same note, because we currently don't use compose, but I'm interested in it. If you were to move the pagination at the top above the connector, would that work?
In our case, yes.
So you could move the third argument to compose above the connector and that would work.
Absolutely.
Okay.
Yep. Yeah, the order is arbitrary. Sometimes in our higher order components, you'll kind of take in a function and then you invoke that function with props so that you can kind of configure the behavior based on props. And maybe those props come from state. So maybe order matters there. But generally, no. They're independent. All right. Whoop. Okay. So I've talked about the layouts. I've talked about the higher order components and the presentational components. So maybe a mental picture would be nice. So this is kind of the picture that I came up with to demonstrate how this is put together. So again, you have your higher order components and your presentational components, which are totally abstract, totally reusable, being composed into layouts. And then you have these big jagged lines around this big routing part. More on that in a second. And then you have the entry point for your entire React Native application surrounded by providers. So these providers provide React context for your application, often attached at the highest point. So those jagged lines are there for a very good reason. And that is because navigation in React Native is terrible. It is the #1 problem that the React Native ecosystem has right now. You have Navigator iOS, Navigator, React Router Flux, Navigator Experimental, React Navigation, React Native Navigation. This isn't even all of them. This is only the ones I have personally tried. Yeah? So it is incredibly important to build a wall around whatever navigation library you ultimately end up using, because you will ultimately end up ripping it back out and replacing it with something else. So that means that if your component, if your file imports from your navigation solution, put it in its own little corner and don't let it infect the rest of your application. Some of these tools promise, oh, you can set these static properties on your classes and then it'll just automatically work. Well, you have to refactor all of that when you're no longer using that tool. So don't let it impact the rest of your application. And you have two main tools to accomplish this: higher order components, go figure, and Redux middleware. With these two tools, you can completely isolate any navigation solution and isolate your pure application from the implementation details of your navigation library. Offline first. So I mentioned it previously, but offline first is very critical to having a great feeling application. It's a bit like saying, mobile first in the web world, right? Targeting the most constrained sort of use case so that the rest of your use cases feel really great. Well, in mobile app development, offline first is the key. So consider Twitter. When you post a new tweet on Twitter, one of two things could happen. It could throw an error at you saying, sorry, you're offline, or it could accept that tweet and post it when the device comes back online later. I strongly feel that the second one is probably a better experience. That having been said, you can't do everything offline. Sometimes you need data. It's hard to give the user the appropriate feedback for what's going to come and what has already occurred. But this ensures a consistently awesome user experience, right? Because sometimes you're in a car, sometimes you go through a tunnel, sometimes you live in Munich. Your network can be terrible. And if you design your application to be offline first, your users will thank you. There is one awesome tool, which won't come as a surprise because it's been mentioned several times already, for accomplishing this, and that is Redux Saga. Redux Saga is powerful, it's expressive, it's a joy to use once you learn it and kind of look past its weird sort of syntax. But it's actually capable of handling the sort of mobile world. Redux Saga isn't just a tool for handling asynchronicity. Redux Saga is what's called a side effect management system, and the mobile world is full of side effects. Every time your device goes offline, every time the user closes their application, every time they hit the Android back button, all of these are side effects which affect your application, and you need to manage them. And Redux Saga is a super expressive way to handle all of them with the same sort of way of working. Now, the most frequent complaint about Redux Saga is that it's too complicated. So we're going to write some together. Here we go. Well, I'm not going to write it. We're gonna walk through it. All right. So first, a bit of background. It actually just came up earlier today. Our application does not directly make network calls from our UI, right? So we dispatch an action for every time we want to access our network services. And there's a good reason for this. So in our application, if you fire off a network request and then close your application immediately, but then come back, that network request will still occur. The result will still come back. If you fire off that network request and we use OAuth authentication, if the user session has expired, well, then when the response comes back, we will actually grab your refresh token, perform an OAuth refresh, get the new access token, attach that to the old request, fire off the new request, and service the result totally transparently to the user. So this is to say, making a simple network request isn't always so simple. And so it's actually quite easy to do this in Redux Saga, so we'll do it together. So here's our to-do list. We're going to first fire fetch based on FSAs, Flux Standard Actions. So these are just standard actions in Redux. And then we're going to persist it to state, right? So if the user closes their app and then comes back, we want to still process that network request. So we need to persist it. We're going to buffer it, right? So if they make multiple requests, we want to keep all of them. And then we're going to add a timeout just in case some weird things are going on. We're going to pause these requests if the device goes offline, right? So you fire the request, but then your network drops. We're going to pause it and then resume it once you're back. And then the big one, we're going to handle multiple of these simultaneously. Well, as simultaneous as JavaScript gets. So we start with what is called the watcher pattern in Redux Saga. So this is kind of your bread and butter Saga. And it's really quite easy to read. Just ignore the yield statement. Often people explain Redux Saga by talking about generators and all this other crap. It actually doesn't matter. Don't worry about it. Just think every line is synchronous, that it has a yield. And the yield function actually doesn't matter. You have helper functions to describe what is actually going on. So the first one that you need to know is take. So if an action is dispatched with a type of request, this function will continue, right? So we're gonna first start up the Saga. It's gonna run forever, but then it's gonna wait until it gets a request action type. The second helper is call. This is super trivial. Actually, you don't need it. It's just a helper for writing tests later. But basically, this will just invoke your function. And fetch here is your normal browser fetch function. And to fetch, we're going to give the payload of our action. So if you dispatch an action with a type of request and a payload with a URL, well, that'll be the URL that the fetch function calls. Next, we're going to put out a different type of action once the fetch call has returned. So Redux Saga transparently handles promises for you. So if you use the call function here, you won't have a result until that promise is resolved. And this res is the promise resolution. So then we're going to dispatch a new action. Any questions on this? Yes?
Is this the same what take every does? Because there's also
Yes.
Okay, so it's
Yes.
the same.
Well, so, I mean, almost the same. Like, if you said take every, you would say take every request, and then the second argument is a function, and you would give it these two lines. Yes. So this is the structure that take every is kind of abstracting for you. Yes. Yes.
You were alluding to this before, but do you have a way to maintain type safety in Redux Saga?
We do our best. It's a pain, right? Because if you say take request, it doesn't really know what that means. So if you had a specific type for every action, then you would simply type annotate rec at this time with that action, and then the rest will be annotated, right? But with some of these helper functions, there's only so much that you can do. Yeah. Okay. Any other questions? Because it's gonna really go downhill from here. Okay. So we have our exact function that we had before, right? But now we're including the original request and the response in the action payload. But actually, the second function that I've included here is a reducer, right? So this is in your Redux state. And basically, it just means that for every request, we're going to store it. And for every response, we're going to remove it, right? So we're only storing in state the active requests, yeah? So details don't really matter there. Next step. Redux Saga provides a whole bunch of helpers for you, and one of them is an action channel. So an action channel will just allow you to get every action that is dispatched for a certain type. So what do I mean? I mean, this part, whoops, this part is going to run forever, right? But then it's immediately going to wait until there's an action in the channel. And then it's going to wait while it makes the network request. But what if at this time another request action is fired? Well, this if you don't use an action channel like this or some other patterns like take every, there's no one listening for that action, so it'll just kind of fire off into nowhere. But with an action channel, you actually get a buffer of all of these requests that you can process. So we're going to take all of the actions out of the channel. We're going to call fetch for each of them and dispatch a response. Questions on this? Yes?
Is there an advantage of using action channel over fork?
No, besides where I'm going next. Yeah.
Great.
Because just like with take every, right? Take every is essentially forking for every action that gets dispatched. You could totally do it in that way as well. But yeah. Yeah.
I have two questions. Do you have a centralized way of managing all network requests, or do
Yes.
you separate them out for? Okay.
Yeah, so we actually have a specific set of actions which are exclusively for making network requests. So they're called, request user, and then you give a payload of the user ID, and then I'll fire off the appropriate network request. Yeah. Did I answer your question?
Yeah.
Yeah.
And the other one is, what about error handling here?
Yeah, so it's not in the example, but you can, of course, do a typical try and catch. And that would catch, I mean, there's really not much to catch, but I don't know. I mean, imagine fetch doesn't return a result, and I was doing like res.foo or something, then this try catch would catch. Okay? Next. Here I've introduced a new Redux Saga helper function called race. So race might be familiar to some people, but basically it means we're going to do 2 asynchronous actions, and then we unblock race, we get a result from race if either of them completes, right? So whichever one completes first, that's our result. Yeah? So we're going to fire off the request, and then we're going to race fetch against a delay. And this is our timeout, right? So we can easily say, okay, you know, I want to wait 5 seconds or 10 seconds or whatever. You could actually configure it per action if you wanted to. You race your fetch against delay. So if delay wins, Redux Saga will actually cancel the other processes for you. But if the result won, then we want to put this result. If the delay won, that is, if the request timed out, then we don't dispatch the result. Yeah? Yes?
One question to delay function.
Yes.
Have you ever experienced problems with the actual time that the delay takes in Saga when you're in debug mode? Because often for me when I'm in debug mode, delay takes like 50 seconds. In production it works fine.
Huh. No, I haven't noticed that. Have you noticed that? Marcus Bay? No. I don't know what to say about that one.
You don't reschedule the request if the delay wins.
I don't reschedule it? Is that what you're saying?
Yeah, or I mean, how would you do that? Like, let's say the delay wins and...
Yeah. Actually, really, really easily, right? So here, I took the request out of the channel, right? So it's missing in the channel. But the channel is still active. It's still live, right? So you want to see how I would requeue this? I say if delay yield put, rec. So if the delay occurred, I'm going to re-dispatch the request action, which will get picked up by this channel. And so when this while true goes to its next loop, it'll actually take it back out. Easy. All right. Next up, okay, so don't get scared. There's a star here. Don't panic. This just means that it's a generator function, which is necessary to use the Redux Saga syntax that I've been using so far. But basically, this entire function is everything that we've done up until this point, right? So let's ignore that, right? So we wrapped everything that we had so far in a function, but now I want to cancel all of that if the device goes offline, right? So here's our fun function race again, which is doing the same thing. It's taking on offline and racing that against a fork, right? So another Redux Saga helper function. So fork is mentally, not physically, but mentally, it's just like fork in other software applications, right? It's a separate task that you just spawn and can more or less forget about. But with race, the combination here is that if an action called offline is dispatched, again, race will cancel this forked work, right? So what does that mean in practice? That means that my request channel is still active, right? It's still taking actions into its buffer this entire time. That doesn't stop, right? But the worker, the thing that is taking the requests out of the channel and actually firing the fetch, stops when the device goes offline. The next function just waits. It'll just pause and wait until the device comes back online. The while true loop continues. The fork worker is called, and the worker resumes processing network requests, right? So let's reflect on what was just accomplished in just a couple lines here, right? Like this would be exceptionally difficult to manage using something like callbacks, promises, async await, right? Correct me if I'm wrong. This would be exceptionally challenging, and it's trivial using Redux Saga. finally, hopefully everybody's with me so far, we want to add parallelism to this, right? So when you're building offline first applications and you Google it, the first thing that you'll come up with is Redux Offline. And you think, great, I don't need to do anything. I've got everything I need here. But there are some major caveats. And one of the major caveats is that it actually cannot process more than one request simultaneously. So let's add that to Redux Saga. We have our worker again. We can ignore that. Here we have the same stuff that we had before, but I'm using a new helper function which I call fork times, right? So instead of fork, it's fork times. And I give it the number of times I want to fork this function. So here, this just is a normal function which takes in the saga and the number of times you want to fork. And it immediately creates a new fork itself, whose job it is to call fork on your saga that number of times. So, maybe the syntax is a little weird, but with this, you're able to process, in this case, 5 parallel network requests on top of everything that we wrote in just a couple lines. So, any questions? Yes?
Yeah, I have an implementation question. How
Yes.
did you do for implementing a reliable offline, basically, action?
This one?
Yeah.
It's actually harder in React Native than one might wish, right? There's there's the built-in network connectivity from React Native, which will give you some events, but in the mobile world, that's not totally reliable, right? So we actually, using Redux Saga, instead of just doing nothing, right? If the delay happens here, we actually say if your request had a network error, if the timeout occurred, we actually manually put the device into offline mode at that time. Yeah.
That's what I do too.
Yeah. Okay.
One question.
Yes.
Let's say you fill up this queue again.
Yes.
Will those network calls be made in the same order again?
Will they be made in the same order? Well, sorry, are we considering the putback that we did before? Because that would put it at the end, right? So it was at the beginning, you suffered the timeout. When you dispatch it again, it'll go at the end of the queue, right? So already,
Yeah, but
you
because
don't
you
have
the
order.
workers.
Sorry?
You don't have 5 workers.
Yes. I mean, they all work conceptually in parallel. They'll just take the first 5 items, right? And then whichever of those 5 finishes first, right? Maybe one of those requests is really fast. Then the while true will just loop and it'll take the next available thing out of the channel. So the channel will reliably be consumed in order. Yes. Yeah. Yeah.
When you go into the offline mode
Yeah.
and spawn back the workers, how do you make sure that actually everything that has been processed is back in the line?
Everything that hasn't, well,
Yeah,
if
for example,
it
you
has
have-
been processed, it's not in the line,
Like,
right? Because it's been processed, so it's out of the channel.
Okay, so let's say we have 3 workers running
Yeah.
requests right now.
Mm.
Then one of them puts in the offline mode.
Yeah.
So everything is cancelled
Yes.
right away.
Yes.
Nothing is there anymore.
Yes.
So now you go back online
Yep.
and
Well,
it's just dropped, or
no. So Redux Saga has an answer to this. I don't know if I can do it so reliably, but here's real fast. If I say try catch, right, that's one thing. But you can actually do a try finally, and the finally will be called when this Saga function is canceled, right? So I said that race here will cancel this function if the take wins the race, right? Well, Redux Saga gives you a chance to do something if that were to occur, right? So then you say if yield canceled, which is a helper function, don't worry about it. And then you can say yield put rec. So you went offline, you have a chance to do something about it, the task was canceled, so put that request back into the queue to be tried again.
And you do it like this, right?
Yes.
Okay. Thank you.
Yep. Okay. Great questions. This actually wasn't supposed to be a Redux Saga talk, but it's okay. Okay, so that was our API module. How do you organize these things, right? So you have all these watchers, they're doing all these things. Well, you could organize it by domain, right? So I mentioned that we have events and members and groups and messaging, and these could be your domains. That's totally valid. Something to consider, we actually organize these things by side effect, right? So I told you that Redux Saga is a side effect management system. We group similar side effects together by source, right? So UI in this case means user input, right? So anytime the user swipes or taps or pulls or does anything, we handle all those things similarly. So those are together. The device, anytime it goes offline, the Android back, any of the React Native device APIs, those are all together. And of course, our API is another module. And these are all isolated, right? So they don't directly execute functions with each other. They all just dispatch actions. It's actions in and out of each of these modules, totally isolated. So we actually enforce this sort of mental model within our root of the entire application. So this is our index.js of our React Native app. And you'll note that we have App Saga, App Store, App UI. These are three completely independent modules with totally different concerns, and they're just being composed together in a particular way. Now, so a note about testing in Redux Saga. One of the supposed advantages of Redux Saga is that out of the box you can test it, right? But in practice, what you will probably find is that whenever the implementation details of your Saga changes, you have to update your test. Well, that doesn't make for a very good test. So if you're using Redux Saga or you want to try it out and you want to write good tests, use Redux Saga test plan. So with this, you can actually mock your state. You can assert on the state afterwards. You can mock on the actions that get dispatched. So truly the ins and outs of Saga functions. So if you care about tests, Redux Saga test plan. So putting this system together, one must form some sort of mental model for how it all works. And this is the picture that I've come up with. It's unidirectional, right? There are three independent modules, the UI dispatching actions into the Saga system dispatching actions to update state, and the UI reacting to those state changes to re-render. Of course, there's this little dotted line called navigation. That's a little practical concession because, of course, you don't want to go to Redux Saga every time you want to transition to a new screen. So that goes direct from the UI to the store, but it's unidirectional. Very easy to understand, very easy to monitor. So this we enforce as well. Oh, actually, that's the same thing that I showed the code for. Never mind. All right. So we've built our application. You know how it's all put together. Now, how do you actually ship this? You deploy it to some users, and boom, it doesn't work. Okay, what do you do now? Okay, let's look at the exception logs. Type error, undefined, e.id in t and t and t and t and unknown and n and connect and n. Yeah, you see this sort of shit all the time. So debugging in React Native can be a bit of a hassle, to say the least. But you do have some tools available. The most basic is React Native Debugger. It's actually just the Chrome debugger, but it's got the major advantage that if you don't focus that window, it won't go into the background on you, which will keep your React Native app fast. So use React Native Debugger. You can use all the Chrome plugins. It's quite nice. But the Saga stack traces, as I mentioned, are bad. Hot module reloading doesn't work at all in React Native, or at least not in my experience. And even debugging network calls in React Native is crazy. I don't know if anybody's tried to debug network calls in React Native, but this is the key. Yes, yes. So React Native actually replaces XML HTTP request. And so if you want to debug, or if you want to see network calls in Chrome debugger, you have to restore it back to the original. So this is the key. That was fun to figure out. So it was mentioned in the other presentation, but stack traces often will lead you into native code as well. So this is one of the areas of development in React Native where having some native skills would be a huge advantage, right? It definitely gives you some necessary context to what's going on, but you know, as I mentioned in our team, we didn't have this experience. You just kind of have to dive in and figure it out and break things, and you can definitely get by. All right, we've solved all of our bugs. It's time to ship again, but it's slow. So how does one tackle performance in React Native? And you noticed on the previous slide that I said Android user. That's not because Android is worse than iOS, although it is. It's just because Android actually was not optimized for by Facebook, right? So when they developed React Native, they developed it for iOS first. This means that you as a developer need to develop for Android first, because that is going to be your performance bottleneck. In our experience, the performance issues always express themselves on Android before they express on iOS. So how do you optimize in React Native? Well, there are three main heavy hitters, and the biggest is re-rendering, right? So your UI in React Native is not free. Every time you have a view component, that view component is not free. This is not a div, you know, that it essentially has no cost. There's a cost to everything, and re-rendering can be a massive performance problem in a React Native application. So now the standard React tools apply. If you're not familiar with them, you have React Pure Component, which you should use by default. Should component update for those specific optimizations. If you're using reselect, you need to cache those selectors. I'm sorry, if you're using Redux, you need to cache those selectors with reselect. Also, using arrow functions or bind in your render methods will cause a prop change, right? So you have to avoid arrow functions in render. And if things really get out of control, we have actually found like a 300% reduction in re-renders by actually debouncing our Redux subscribe, right? So you could debounce dispatch, but actually all of your components re-render on the Redux store subscribe function. So you can actually debounce this and get really significant performance gains. So check out Redux batch subscribe. The second optimization, which is absolutely critical, is to do navigation on the native side. So I mentioned React navigation. This is the so-called official navigation solution for React Native. We actually had to rip it out and get rid of it because it wasn't performant enough. So now we use Wix's React Native navigation, which does all of the navigation on the native side instead of on the JavaScript thread. So this is critical optimization. And I mentioned it before with the indexes and state. The path between state update and render is a critical one. So you need to reduce the amount of work that happens here. So don't do anything expensive. Otherwise, no big issues so far. So how do you scale this? And this is one area where React Native presents some unique opportunities. So I mentioned that we have hybrid applications. Well, this is actually how we intend to scale. So we have an experimentation framework already that exists, which does A/B testing, right? So some percentage of users go here, some percentage of users go there. We actually hooked up both of our hybrid applications in iOS and Android to this experimentation framework, and then we actually split our users between the existing hybrid app and the React Native app. So we've actually embedded our entire React Native application inside of the hybrid app. And with this, we can actually smoothly scale from 0 to 100% rollout, controlled completely with the experimentation framework. So this is totally something that would be impossible without React Native, but we were able to do it both for iOS and for Android. So you can really do crazy things to scale a React Native app. So we've rolled it out to some people now. How do we actually make sure that it's working? Well, there's an awesome tool called Microsoft App Center. So Microsoft bought Hockey App and then released App Center. And with this tool, you can do like releases, builds, crash reporting, event monitoring. But the awesome thing about it is that it works with code push. So you get JavaScript stack traces in your crash logs, which is a unique feature that Microsoft App Center has. So it's really nice to use. This is what it looks like. So you can see down at the bottom here, RCT fatal exception, unhandled JS, but you actually get line numbers, right? So you get real files, real line numbers, so you can trace your JavaScript exceptions. Now, after all this talk, you might wonder what the app looks like. So this is it. If I can hit play. So I'm just kind of going on a little, or not. No, I'm not going anywhere. Oh, here we go. No, I touched it. Oh, it's actually playing on my screen here, but not on the other screen. That's weird. Can I drag this over? Oh, okay. So we're scrolling, we're clicking. So we've got an activity feed, side scrolling event list. We have native map integration, gallery views, image swiping. You can see all the transitions, photo uploading, contacts. Hey, there's me. Yeah, so a lot of features. And then there's another one. So this is our messaging system. So we built an entire chat app using React Native. So here I can search for people. Now it's playing better in the background than it is in the foreground. It just cannot make up its mind. Okay, so here I am sending a message to Marcus, who's in the back. I swear that actually is not a React Native issue. That is a video issue. I don't know what is going on here. I apologize. Okay, so here I'm creating a group chat so you can select people. It's got the pop-in animation. So hopefully this gives you a sense of what the app is like. So one of the frequent questions when talking about React Native is, how much native code do you have to write? Well, for us, none. Well, almost none. So there are some little exceptions. I mean, one, of course, the open source community is critical here. Our navigation, implementation, push notification stuff. I mean, we use open source tools that write a lot of the native code for us. You do have to know Xcode and Android Studio for some of these things. How much code is reused between iOS and Android? I would say a conservative estimate is 95% code reuse between these two applications. So of course the time saving is absolutely amazing. So what? So maybe you're not building an application like we are. Why do you care? Why do you care about this? Well, the cool thing is that for all of these common software development problems, right, These are generic problems for rolling out any native application. There are solutions in the React Native ecosystem, and these are just some of them, right? So your solutions will differ. But the solutions are out there, and you can do it. So I've mentioned a lot of JavaScript libraries, and these are just some of them. So maybe some of you are suffering from JavaScript fatigue at this point. So I added a helpful star scale on the right, and it's not how good the library is, it's whether you should care about this tool, right? So you have from Calabash and Detox to, who cares, to Prettier and ESLint, where everybody should use it, but 5 stars is reserved for React Native. So check it out. So thank you to my team. They were critically involved in some of these decisions and putting all of this together. And thank you to all of you for listening. Questions?
I have one for code push. Did you ever run into issues where you had a wrongful update and then users would have a destroyed state?
Well, so first, if during the rollout users experience issues, like actually upon the first run of the application.
So that is one full render pass, an exception there, or how does it know what is an error?
Good question. Actually, I'm not sure, but Code Push has a tool to stop the rollout and roll back.
And roll back.
Yes.
Yeah.
Yep.
So let's say the application is broken.
Yep.
You can still
roll it back.
recover that? Okay.
Yeah.
Actually, it even does it automatically.
Yes.
Partially.
Yes.
So it detects that if its users get the problem, then it will just roll back and say, you just did bullshit. I just rolled back to the state where it was working, and
Yep.
it's actually working pretty good.
Yep. It's great.
One question about the testing. Did you test on real devices, or how did you?
Yes. Yes, definitely.
During development.
Yes, during development it's actually very critical to test on real devices. When it comes to performance, if you have, if you're testing in a simulator, but even if you have the debugger attached, the JavaScript is actually running in Chrome, right? Chrome on your desktop, right? So it's going to be really fast. So especially for testing performance, it's very important to test on a physical device. Yeah.
Yeah, I think I can just mention one funny incident that we experienced where the Android simulator was smart enough to increase the heap size of the memory. So we never had any real memory issues when we tested it in a simulator.
Yeah.
But then a real device was not as smart to do that. So then the app
Was terrible.
Performed a bit slower, and there was not so much memory.
Yeah. Yeah.
I saw in the video presentation that you use some animations.
Yes.
And that's very important for native development.
Yes.
I'm Android developer, so I'm working on Windows. And how do you debug animations? Do you have any experience? Because for me, animations when I'm in debug mode, you cannot see what's happening until you go into production mode.
Between release and production.
Yes, in production everything works, but in debug,
it's definitely more jittery. Yeah. I'm sorry, I don't really have anything unique to offer there. Honestly, I haven't had significant issues with the animation. I mean, we don't really do very heavy animation, just kind of pop in, pop out, swipe, zoom, I showed the image gallery, you can pinch to zoom and these sorts of things, but we haven't really done any complex animations where I would actually need to debug it. Maybe you're hitting an issue with animations running during complex JavaScript operations, which can cause jank on the animation. There's a tool for that, and it's the run after interactions. So you can tell your expensive code to wait until all animations and user input are complete with the help of the interaction manager run after interactions. Anything else?
Yeah, you mentioned Jenkins, I guess, at some point.
Jenkins, yes.
Why are you using it, or what are you doing with it?
Honestly, we use it because it was already existing for our web applications. Yeah. Yeah, I can't say that it's you know, uniquely powered for React Native. You know, it'll just run anything. So yeah. Yeah.
How much time did it take you and your team to finish this?
Yeah, so what you've seen is the two back end, 3 front end for a little under a year.
And how much people? How many people? Sorry.
2 back end, 3 front end.
Sorry.
It's okay. Yeah. Yeah.
So,
All right. Oh.
So sorry,
Yes.
compared to a hybrid application, it was much lesser.
Yeah, we've spent less time than they did on the hybrid apps, and we're getting both fully native together without reusing a whole bunch of web views. So, yeah. Yeah.
You made a strong case for static typing in the beginning. What's
Yes.
your how would you convince somebody who's more into writing tests? Because in a way you still have to write tests, right?
Yes, totally. How
Why
would I
should you use
convince?
static typing?
Okay, well, I think there's multiple arguments I could try. I'll try refactoring, right? So the refactoring experience in our application is really nice. Like, we can just go and update our state shape, for example, and just fix all the flow errors, and 99% of the time the application works, you know, because it's really strictly annotated. So type annotations, if nothing else, makes refactoring time significantly less. Yeah.
Maybe also on top of that, about static typing, I'm always worried about tooling. You mentioned that, for example, ESLint broke just with flow or flow. I thought that flow, or the advantage of flow over TypeScript would be that you just use Babel and the rest will come automatically, but it's not true.
Yeah, this was, gosh, I can't even remember the name. There was some underlying tool that that indeed Babel was using to understand the syntax that actually didn't support it, or did support it, and ESLint hadn't updated their dependency yet. I'd have to check the issue to remind myself, but it was actually under the hood a Babel related issue. Yeah.
Is that often?
No. Thankfully. Oh my gosh, that'd be terrible.
And
Yes.
you mentioned a lot about development, but how are the metrics? Is it better for the users? Because actually we do that all for the users, so how is it going?
Yeah, well, I mean, we mostly have user test feedback at this point, and you know, we're still in active development in the rollout phase. But I mean, almost universally, whenever we put it in front of someone, they're like, "Give it to me now," because the hybrid app is so slow, you know. And if you're on a bad network connection, you know, you're just looking at white screens, right? So it really feels terrible. And so being offline first with a fully native application, it's a dramatically improved user experience. Yeah.
You want to show it live?
Oh God. No, come up and talk to me, and then I'll show you it. I'll be happy to. All right. Thanks, everybody.